Assalamualaikum. Welcome to the Basics of Python video series by UrduITAcademy. Today we are going to learn about exception handling. So let's get started. So what is an exception? So an exception is an event that disrupts the normal flow of a program. Okay. So it essentially an error. It's an error that occurs during the program's execution, which means it will happen whenever we are running the code. Okay. And as I said, it will disrupt the normal flow of the program. Okay, and it will make the program crash. Okay, so exception it's an error, but it's not like a syntax error. Okay, so because the syntax error occur when a Python interpreter can't understand the code due to some incorrect syntax, just like a missing colon, an incorrect indentation, or a misspelled keywords. Uh, for all those reasons, we can get a syntax error. But exception will happen, whenever we are running the code, there won't be any error. So exception will happen, whenever you're running the code, it's like not regularly, sometimes, whenever the user is giving a wrong kind of some kind of error, like, whenever they are trying to divide a number by 0, something like that. In that cases, whenever you're running the code, the exception will happen. Okay. All right. So why do exception occur? Exception occur due to unexpected condition that the programmer didn't account for. Okay, it could be a user input error, which means whenever a user is trying to enter a letter, when there is a number is expected, which means the line we are writing a code like number equal to int input entry number. So int input means the computer is expecting an integer, right? But if the user is typing any string, any letter, this will give a user input error. Okay. Now, file handling error means trying to open a file that doesn't exist. It can lead into file handling error. Network issues can happen, like trying to access a website that is down, or due to resource limitation, like running out of memory. So these all cases can lead to exceptions. So why is exception and one more thing, without proper handling, this error can crash your program and leaving the users frustrated. Okay, so exception handling is very important. Okay, because it prevents program crashes. Uh, as I said, if exceptions aren't handled properly, your program will stop abruptly. Okay, whenever it is encountering an error. So exception handling allows your program to manage the error gracefully and to keep the program running. Now, it will improve user experience. Users are more likely to trust softwares that will not crash, right? By catching an exception, you can show a user-friendly error messages. Whenever there is an exception happen, you can just, instead of crashing your code, you can just send an user-friendly error messages, instead of, cryptic Python programming error message. And it is very useful in large application, because in large application, the coding will be very complex. So especially those interacting with databases, files, or external APIs. So exceptions are almost inevitable. So in this case, proper handling ensures your application remains stable. Okay. For example, imagine an ATM machine. Okay, an ATM machine software that will crash whenever a user is typing a wrong password, or sorry, a wrong or in an invalid pin. So instead of crashing as ATM machine, it will be, it's better. It can show a friendly message like invalid pin or please try again, something like that. Okay. Here you can see this is a basic structure of exception handling. Okay. So here, whenever you want to write an exception, uh, code for exception handling, first you need, sorry, first you need to type try. Try means inside the try, you have to add all the code that might cause an exception. Okay, try colon. Inside that, you need to add all, usually whenever we are asking the user to enter two numbers, we can add it inside the try block. Okay, because if the user, instead of a number, if the user is typing a string, it can lead to an exception, right? So whenever such exceptions are happening, the computer will execute the except block. Here we can print something like wrong input, try and next time type a integer value only, something like that we can print. We are trying to divide by 0 and we are going to handle it with an exception, except keyword, okay? So here inside the try block, I'm directly typing result is equal to 10 by 0. So you know that we cannot divide a number by 0, right? So in that case, usually it will give an exception and the program will crash. But here, since we are adding this line inside the try block, it will lead an exception and it will print error. We cannot divide by 0. Okay? And the program will continue running normally. Now, catching specific exceptions. So specific exceptions help us understand which errors are expected and how they should be managed. Which means here, for example, I'll show you something. So here, as you can see, I'm asking the user to enter two numbers. I'm dividing the number and storing the result in the answer. Then I'm printing. It is a very simple code, right? Whenever I'm running the code, as you can see, there won't be any error. Now typing a number, maybe 5. Second number, maybe 2. Whenever dividing, the answer is 2.5 because 5 by 2 is 2.5. Right? There is no error. Perfect, right? But here, there can be an exception whenever the user, instead of typing a number, if the user is typing a letter, some letters straight. You can see the program crashed. It's saying value error, invalid literal for int. See? So this is an exception and the exception is value error. Okay? So this is one kind of exception. Okay? Now, the second kind of exception can happen whenever I'm typing the second number 0 is 0. Here you can see it is giving zero division error, division by 0 because we cannot divide a number by 0. Right? So these are the two possible exceptions which can occur. Okay. So what I am going to do is that all this code, I'm going to add it inside the try block. As you can see, try colon in the next line, I'm just pasting it. Okay. So if there is any kind of exceptions are happening, instead of crashing the code, we can write an except block. Okay. We can print something like error happened. Something like that. Okay. So as you can see here, instead of typing a number, if I'm typing any letter, instead of crashing the code, instead of happening a value error, it's printing error happened, try again. Now below that, we can write the normal code. Okay. Coding. Maybe I'm just typing normal coding. Continued. Something like that. Okay. So you can see when there is no error, it will print the answer and it will say normal coding continued. And if there is any error, maybe I'm writing a letter, it will print error. It will go to the exception and it will print error happen. After that, it will continue with the normal coding. Clear? So here, as you can see, two kinds of error can happen, right? Value error or zero division error. Whichever error is happening, it will print the same as a error happen, try again. So it will be better if we can specifically print if we can print a specific message like zero division error happened or value error happened, something like that, right? So catching a specific exception is important. Specific exception help us understand which error are expected and how they should be managed. Which means if there is a value error, we can print a specific message like, it happened a value error. You should be careful. You should only type integers. And if the zero division error, like, if the second number, the user has written 0, we can print something like, we cannot divide a number by 0. You should enter only a positive number or any number other than 0, something like that. Okay, so it's better to catch specific exception rather than using a general except block. Okay, so because it will help us in debugging. Like if your code catches exception blindly, it becomes hard to identify what went wrong. Okay, and it will improve code clarity. Okay, which means when you handle specific exception, it's easier to understand what kind of errors you're anticipating. All right, and it will prevent unintended behavior, which means catching broad exception can mask unexpected errors and potentially causing your program to behave incorrectly. Okay, so it's better to have specific exception, different exception except blocks. All right. So the commonly used exceptions are zero division error, value error, and type error. Okay, there are many more. Okay, here you can see try instead of adding an like regular, I mean a normal symbol except block. Here you can see I'm only adding a common except, right? Instead of that, here I'm clearly specifying value error, which means whenever the user is inputting a number, executing this line, only if there is a value error, then only this execution will, is this except block will execute. Okay. So whenever here you can see, uh, if the user, here you can see int, we are converting something into an integer, right? So if you are converting int inside the bracket to 12.5, a float number we can convert into 12.5, we can convert into 12 only integer. But ABC we cannot convert into an integer number, right? So whenever a line like this happen, it will make give an exception, a value error. So in that case, we can print error cannot convert to an integer. Okay, the error message we can print. Now here you can see in this example, I have two except block. We can have multiple except blocks in the same code, okay, it's for the same try. So inside the try block, as you can see, num equal to int ABC, result equal to 10 by 9. Two kinds of error can happen. So the value for the value error, it will print conversion error invalid number. And for the zero division error, it will print math error cannot divide by 0. Now here you can see result is equal to 10 by 2. Okay. So here we are accepting a zero division error, print cannot divide by 0. Also, we can have an else block. Else block means if the exception did not occur, which means if there is no exception, then the else block will be executed. Here you can say 10 by 2. We are dividing it by 2, right? So there is no error. The answer will be 5. So in that case, computer will not execute the except block. It will just directly printing division succeed and the result 5.0. Clear? All right. Now the final. Okay. So handling specific exceptions are important. So yeah. Now the finally clause. The finally block clause is always executed whether an exception is raised or not. If there is ever any exception or not, the finally will always execute it. Okay. So the finally block is used in conjunction with the try and except block. It will always execute. Okay. So it defines a block of code that will run no matter whether the exception is raised or not. Okay, so the main purpose of finally is to release the resources, to close the file, to disconnect the database, or to perform any cleanup task that should happen whether the error occur or not. All right, so the finally ensure the cleanup of the code runs no matter what will happen. Okay. For example, in a real life situation, you can think it like imagine you're renting a car. Okay. So whether you trip to go for a trip or for a vacation, okay, just think, okay. So whether your trip goes smoothly or you encounter some kind of issue, you always need to return the car at the end, right? The rented car, you always have to return. Okay. So the finally block ensure that the car or the resource are returned no matter what happens. Right? So this is a pro example for finally. So inside the try. Okay, inside the try, we are trying to open a file. Okay, this is a file. We are going to open a file. Okay, so the file management, we are going to learn the file management in our next video series. But just consider, look at this example here. Just remember that I'm just trying to open a file. Okay, suppose if there is no file named as data.txt, in that case, it will give an error, file not found error. So in that case, it will print file not found. So even though error happens or not happening, the finally block will always execute. You can see it's making an error, exception, and it execute the finally block. So, okay, this is when the error is happened, and this is when there is no error. Even though there is error or not, the finally block will always execute. Clear? Now the next one, raising an exception. So the raise statement is used to trigger an exception manually. Okay. Here it allows you to stop the normal flow of the program and jump to the except block if there is one. Okay. So the raise keyword is used to raise an exception. We can decide what kind of exception to raise and the text to be printed to the user. All right. So imagine you are a classroom teacher. And if a student does something wrong, you can raise your hand to alert everyone that there is an issue, right? So the raise statement acts like that hand, okay? For following issues in your code, you know, when certain, it can raise some exception when there is certain conditions are not met. This is an example. Here age is equal to -5. We are checking if age is less than 0. If it is less than 0, we can raise an error value error. Okay, we can print a message like value error. Age cannot be negative. Okay, so we can create an we can raise an exception by our own manually. Okay, I hope it's clear. So here itself, as you can see, we can write multiple kinds of exception, right? Like you can see except value error. If there is value error happening, we can print something like only enter integer, please. We can print it something like that. Same way, if there is zero division error, we can print something like, oops, we cannot divide. See, sorry. Clear? Same way, if you want to raise an exception, here you can see, I'm asking the user to enter a number. Maybe I'm checking if the number n1 is less than 0. We can raise maybe value error. Clear? Whenever the n1 is less than 0, we can raise the value error and we can print something. Like we can print a message also along with that, like value error. Inside the bracket, we can print something like number should be greater than 0. See? Same way we can, if something like that, we can check something like that if n1 maybe greater than 100, we can raise another exception. So you can raise value error like, and we can print something like it should be, or number should be less than 0, or number should be less than 100. Clear? So like this, we can raise an exception by exception manually. I hope it's clear, because the exception handling is very important whenever our program go larger and larger, or whenever you are going to create a real life applications. Exception handling is very important, because no user will prefer a software or a program that will crash in between. I hope it's clear. Have a nice day and see you with another video. Assalamu alaikum. Bye.